Hello, my name is Kainton Mononye. I'm still the application developer and the computer engineer. And in this video, I'm going to speak on telecommunication or communication systems. I'll just give a general overview and I highlight how information is transmitted from the source, you that is talking, to the recipient. So just like I'm making this video, I'm speaking and you get this information and then you're able to use it. But the focus is actually telecommunication in terms of people speaking and the receivers getting this message in real time. So basically, although telecommunication has got something to do with data transmission, but the focus here is voice data or voice information transmission in terms of sounds, and that is the focus of telecommunication. Before now, in the way back in time, we have various communication systems whereby people pass message from one location to another in different ways. For instance, making a very loud noise or sound that travels through the waves to certain distance of a few yards or thereabout. But that's not what we are going to be talking about. We are going to be focusing on digital telecommunication and basically telecommunication system as it is used today. I'm not going to make a detailed explanation of everything about telecommunication system, but I'm going to give a general view and then I explain the various components that come together to make up the telecommunication system, you say. So what happens when you pick up your telephone, your fixed telephone or your mobile telephone? You speak to the telephone and then the receiver picks up the call and then receives your message, and you exchange words, you exchange information. So that is what I'm going to be focusing on. So I'm going to just give a general overview. First, I would like to say that voice information is generated from a source and it goes to a transmitter, to a channel. Channel is a medium of communication. It goes to a receiver, then it goes to a sink. Take note, these are 5 important components. The source, that is, for instance, me speaking, I can be the source. Then we need a transmitter. Well, if you are speaking in a telephone, the transmitter is built into your telephone or your telephone system, and have the channel, that is the medium through which the information will travel or your voice will travel. Or have at the other end we need a receiver, which is also a telephone system, and then we have the person, the sink, receiving this information. So these are the main components. So what actually happens is when you speak, your voice is generating signals in form of waves, and these waves is in analog form. What it means is that the sounds we make generate signal that can travel through a medium, and signal being generated is an analog waveform. What I mean by an analog waveform is a waveform that has a continuous set of stages it passes through. The stages or the movement of this waveform is not discrete at discrete levels. So you can have it ranges from, let's say, from 1 to 100. In between you have several levels. It can go up, down, just like that. So in another video I'll have to present a diagram to explain exactly what I'm saying, but the point I'm making is that the signal generated in your voice is an analog signal, and then it has to be converted to a digital form to be transmitted through a transmission medium. So now, how do you convert from this analog form coming out from your voice to a digital form ready to be passed into a transmission medium or a channel? And there you have a number of components. I would just like to list these components, and then in a different video I explain them. One, you have the sampler. That is, the signal is sampled at a particular rate. If it's sampled at a particular rate, it now can be confined into discrete levels, but just continuous. But know that it's not digital yet, but it's being sampled and several discrete levels have been created. Digital simply means 1 and 0. So how do we take all this series of levels have been created, the samples, and convert them to digital? So the first component there in the communication system in terms of the transmission, we have the sampler. So after the sampler, we have another component. This component is called the quantizer. The quantizer is just a system that rounds up values to a set of given values. What it means is that if you have 1, 1.5, 2, 2.5, 3, 3.5, 4, just like that to 10, the quantizer may be able to just round them off to the nearest whole number. So if we have 1.5, 1.75, the quantizer may just take them and just approximate to the nearest whole number. For instance, 1, 2, 3, 4, or 1, 5, 10, 15, 20, and the quantizer has a set of values. Each number have to be rounded off. So for instance, we have 1.7, 1.8, 2.1, 2.3, all this one can be rounded off to 2. So that's the work of the quantizer. And now the next step is called, another component is called the symbol to bit mapper. Well, the symbol to bit mapper is a device or a component that grabs the information that is generated by the quantizer and maps them to a binary form. It means that you may have 1, 2, 3, 4. So coming out from the quantizer and going into the symbol to bit mapper, and now the symbol to bit mapper may assign 1 to 1, 2 may be assigned to the binary equivalent. Let's say that is 1, 0, 3 can be assigned 1, 1, and then we have what we have at the long run is a series of 1s and 0s. So I'm sure you followed. You know it might not be very clear, but I hope I just made a point. So what we ended up doing is we grabbed the signals from you, the analog sound coming out from you, pass it through this set of systems I've explained, although not in a very clear way, and what we have is a digital signal. Now, some might also like me to mention something having to do with modulators. What is modulation? Well, I just give a clear explanation. Modulation means the process of modifying a particular property of a signal with another signal. Let me give an example. For instance, a signal, or let me repeat my definition. Modulation means modifying the properties of a signal. One or more properties of a signal, you modify it using another signal. So how it applies to telecoms is, for you to transfer information from a source to a destination, it has to be packaged into a medium. So now this information coming from you has to be carried. Even though you are producing a signal, that signal you are producing have to be placed inside an envelope called the carrier signal. And the carrier signal, your information comes inside, exactly inside the carrier signal, and it moves your information from the source to the destination. So when you modify the carrier signal with the signal you are generating from yourself or from whatever system you are generating it from, you have modulation. So modulation can be of two types. We have analog modulation and digital modulation. In analog modulation, we have three forms: amplitude modulation, frequency modulation, and phase modulation. I would like to just give a function of a signal, or how a signal can be represented mathematically. I don't have a whiteboard, I don't have a digital screen for now, but in another video I just subscribe to my channel, I'll be able to use that to make my explanation. Let's say a signal of, let's call it S, a function of time, is equal to A cos omega t. Now S, which is a function of time, let's say is the signal, A is the amplitude of the signal, then omega is the frequency, then we have the phase. So we say S as a function of time is equal to A cos omega t plus phi. We have this phi introduced there can now be the phase. So what I'm trying to say in effect is a signal has three fundamental properties: the amplitude, the frequency, and the phase. So these three things can be modified with whatever value, but modifying it, you are modulating. So that is how it works. Now I want to point out modulation have two areas. We have the digital modulation and the analog modulation. Analog modulation, we have three types of analog modulation. Amplitude modulation, as you know, it means to change the amplitude of the carrier waveform. You have the frequency modulation, FM. So you know, everybody knows about the FM radio. It means modifying the frequency of the carrier waveform. You have the phase modulation, modifying the phase or the phase angle of the carrier signal. And digital modulation, we also have three parts, although these parts also have sub-parts. But I just mentioned the three basic types of digital modulation. Amplitude shifts keying, amplitude shifts keying. That is ASK. Amplitude shift keying. Frequency shift keying, FSK, and phase shift keying. These are the three aspects of digital modulation. So I hope this video, although it's not been very clear, but I hope it's been informative for you. And subscribe to my channel. I'll be making more great videos after now. Questions I would like you to ask me, and of course I'll be ready with the answer for you, is how do we represent this signal in mathematical terms, or how do we create a model to represent the signal? Again, how do we handle interference in terms of noise when we are transmitting the signals from one location to another? How do we handle the effects of noise? And another thing I also think you might be asking is, when you are converting from analog to digital, are you not losing some information? Because you are actually rounding off a continuous signal to whole numbers and then changing to binary. When you round off, are you not losing information? So this I'll also explain in another video, but just subscribe to my channel and be sure if you are going into telecom, so you want to line